ideal for joining blades to discs in turbine manufacture. They're called blisks. And these are some images of welds made on the new Limfrick machine here at Addington. Well, successful welds were achieved in a variety of section combinations. The linear friction team also examined the process with titanium specimens.
So this is what linear friction welding. I think you have seen the applications also, because rotary friction welding I have shown some applications. Linear friction welding is mainly used to join the blades in the turbine. So now if you look into that, I have shown the diagram, right? Now this is about the linear friction welding, right? Now coming to the next one is the friction stir welding. This is another concept similar to friction welding. So when I say friction stir welding, again this is a solid state process. Now I have two metal pieces. Now what I am going to do is, I have a pin. This one normally called as a pin. What I call this one as a pin. These are two metal pieces which I am going to join. Alright. Now what I am going to do is, I am going to join these two metal pieces. Now this pin, what happens, the bottom, you can make it different cross sections, a circular cross section or triangular. The pin can be of different cross sections. Right. Now you just insert it, and when you start rubbing, now what happens is, this acts as an electrode as well. Right. Now what happens, this rubs the metal, puts the metal in a plastic state. You got what I said? When this is moving like an electrode, this keeps moving like an electrode. Right. Now that, again, similar to friction welding, you get the welding to be done. But here, one advantage here is, because friction welding, it is applicable only for rotary components. Or if you think about linear friction welding, it is applicable for components with thicknesses beyond 20 mm or 25 mm. So below which, if you go for linear friction welding, it is not comfortable. It is not comfortable to produce that much amount of energy for dyeing. So this particular process will support you even if the plate thickness is very less than 12 mm. You understand? So that is why we go for this particular process. Now here most important thing is parent metal plates and this pin. This pin plays a vital role. So cross section is changed, how the weld strength is changing. Lot of work is going on as of now. By changing the cross section, and how you can improve, because the strength keeps on varying. Now if you change the cross section of the pin, the strength of the weld bead keeps on changing. So that is what very important here. So if you look into this one, friction heating, so I have already told the same friction heating is used. So you have a non-consumable electrode, but pin plays a vital role. That's stirring. See, what is the purpose of pin is, once it creates a plastic state, you have created a plastic state. Now that plastic state has to be, that molten metal has to be stirred in such a way that the plastic state metal is uniformly distributed. If you don't stir it, you create, now what happens, the plastic metal will try to solidify at one end, probably it may not go where welding is required. Now that is the purpose of pin here. Now rotating tool is made of hard wear resistant metal, mainly made of carbides, right? A tool rotates with a speed of several hundred RPM, slowly plunging into the joint line of the workpiece to be made. This is the process here. Now these are different types of joints which can be made. Right now this was mainly invented by 1991, the recent welding process, probably just before you have been born. Right now this process, if you look into the research again, if you look for friction stir welding, people work only with aluminum alloys. Because if you work with some other metal, say that I am going to join, it is again useless. Why you go for aluminum alloys? If you weld aluminium by any other process, it will be followed by a hairline crack. This friction method is alone showed some improved results in welding aluminum alloys. Now that is what very important. If you say that nobody has done welding in some other metal, I am going to do, it's a costly process, and you can do in gas welding or arc welding and complete it for some other metal. As far as aluminum is concerned, you can even test it with other electric arc welding process. But at the end of the day, you should go for NDT testing and find out what is the defect inside. Just looking at the naked eye, you cannot find the defect. but there are defects. That is a proven. If you look into journals, you can see a lot of defects. You cannot weld aluminum at all by any other process. Now that is what the literature says. You understand? People have worked with aluminum, not possible. So in aeronautical industries, aluminum, if you want to join, they will go only for riveting. They will go only for riveting. But nowadays, they go for friction welding process. This is again
It's
aluminum.
possible to join aluminium up to 75 millimeters thickness using friction stir welding on both sides.
On both sides. Now that is what very important.
And here we see it viewed by a thermal imaging camera.
Right. Now comes the next one, the latest
Ball
one.
bonding is a technique for interconnecting silicon.
This particular is the most advanced method. Right now, I cannot go deep into this one. But as of now, there are something called micro joining, micro welding processes. Right now, if you say about micro joining and micro welding processes, so you have a current with 0.5 to 50 amperes of fusion process, thickness, okay, and often microscope is used to see the joint. That is what very important. Now when I say micro welding or micro joining, now you need a microscope to see the joint. Right now there are different types of micro welding processes. Micro resistance welding, right? Micro resistance welding, micro plasma arc welding, ultrasonic welding, low power lasers. So now these are some of the techniques. Of course, lasers you would have seen. But the remaining thing probably you would not have seen. So let me show you some of the joints which is prepared.
Ball bonding is a technique for interconnecting silicon chips. Ball bonding is a technique for interconnecting silicon chips. Here we see ball bonding of 200 micron diameter aluminium wire. An arc is used to produce a ball on the end of the wire. The ball end allows a multi-angular bond placement approach. It is pushed down and ultrasonically welded to the chip. The wire can then be led to a lead frame or the substrate and wedge bonded. The process is normally used with gold wires. Wedge bonding is used mostly on aluminium wire.
Right. Now I want to tell you something about this one. So when I say ball bonding, now you have a wire here. Now you just melt this part. You just melt the tip. This is the wire which is to be joined. You just melt this part, then you make a bond. Now the melting process is also explained. I have seen it or not. You generate an arc, bend to this particular portion, then you apply pressure. The solidification happens in the substrate. So this is the ball bonding. Now again, the weld can be seen only using a microscope.
Ball bonding is a technique for interconnecting silicon chips. Here we see ball bonding on 200 micron diameter aluminium wire. An arc is used to produce a ball on the end of the wire. The ball end allows a multi-angular bond placement approach. It's pushed down and ultrasonically welded to the chip. The wire can then be led to a lead frame or the substrate and wedge bonded. The process is normally used with gold wires. Wedge bonding is used mostly on aluminium wire and is a reliable method of joining silicon devices to substrates and lead frames. Both processes can be automated to achieve speeds of 3 to 10 loops per second.
And I think you would have come across, you would have seen electronic components, right? You would have seen electronic components. Most of them are by the welding technique, particularly micro welding process.
And here we see ribbon bonding, which is used primarily in high-frequency devices. Management system are joined here using a wedge-wedge wire bonder.